All right, I've started with Bernoulli's Bernoulli's equation. I am going to now fill in things I know or eliminate things I don't need. So one thing we need to do is figure out how we want to label the different positions in the picture. Do you want to call this 0 and that negative 15, or do you want to call that 0 and that positive 15? 0 at the top and negative 15 here. It doesn't really matter how you do it, as long as you're consistent with your picture when you assign the values to the variables. All right, now, very careful. If I'm a water molecule sitting on the surface of the lake, what kind of pressure am I subjected to?
Atmospheric.
Atmospheric pressure. Okay. So this is P atmospheric plus 1. Oh, okay, I'm not done yet. If I'm a water molecule sitting on the surface of the lake, what is my velocity as I sit there? 0. It's a reasonable assumption we can say it's 0. So this piece will be 0. And what is the position of that water molecule according to the way we've defined our coordinate system?
0.
0. It's at 0 height, so to speak. Now be very careful here. If I'm a water molecule, as I break free of the dam, what pressure am I exposed to? I'm coming out of a
Atmospheric.
crack in the dam. What pressure am I exposed to as it leaves?
Isn't that still atmospheric?
Also atmospheric, okay? Do I know V2? That's actually what I want to find, right? So we're going to say 1/2 rho V2 squared. And then what is my position on this coordinate system that I've defined?
Negative 15.
-15. Rho V. So what do you notice about this problem, first of all?
You can set it equal to 0.
Yeah, the atmospheric pressure is the same on both sides. Go ahead and subtract that from both sides. So it turns out that I get 0 equals 1/2 rho V2 squared minus rho G. We also notice that the densities cancel. They're the same in each term. Divide. And you'll end up with V2 equals square root of 2G times 15. Does that look eerily familiar to something we've done in the way past? How could I find the velocity of this falling ball just before it hits the ground? Ignoring air resistance. So the PE here is mgh. What's the kinetic energy at the bottom? What is it? Not 0, just before it hits. So mgh equals 1/2 mv squared. Solve for v. What do I get?
17.146.
No, here? Here, I get V equals square root of 2GH. That's pretty cool that this energy thing keeps popping up all over the place. It's as if I dropped a water molecule, so to speak, from a distance of 15, and its velocity as it comes out of the crack in the dam is square root of 2GH. Okay. All coming from a different approach, but a very similar result. Yes? Okay, should we try another application?